Very good morning to one and all. Welcome to Radiobytes. Today we'll be seeing on the parts of an X-ray machine. So the X-ray machine basically contains the following parts. Here you can see the cathode made up of tungsten filament, and the anode is made up of a copper stem with a tungsten target embedded in it. All these components are enclosed inside a glass envelope, and here you can see in the cathode side a U-shaped focusing cup which is made up of molybdenum. So as the power supply is switched on to the X-ray machine, this tungsten filament will be heated to red hot. It will start expelling electrons, and this molybdenum cup, this is also negatively charged, and the electrons produced by the tungsten filament is also negatively charged. So the work of this molybdenum focusing cup is to repel the electron produced by the tungsten filament towards the tungsten target. As it goes and strikes the target, we will get X-rays, and this X-rays will exit the X-ray machine via the tube window. And you will be having aluminum filters here in order to filter the low energy electron, and only the useful high energy electron comes out as a diagnostic X-ray beam. That is only given here as useful X-ray beam. So this forms the picture of an X-ray machine. So the probable questions which you can expect from this section are, why are we using tungsten as a target? See, in the picture I showed you, the tungsten, the filament here is also made up of tungsten, and the target here is also made up of tungsten. This is because we prefer using tungsten mainly for three reasons. It has high atomic number 74, and the melting point of tungsten is also very high. I have given here in Celsius, Fahrenheit and Kelvin the melting point values of tungsten, and the vapor pressure of tungsten is also high. And the atomic number, as I said, is very high, and it is 74. Usually when an element is going to have high atomic number, it will have electrons in the outer shell which can be expelled easily. And this tungsten, which is having an atomic number of 74, is preferred because it can expel electrons to a larger extent and help in the production of high energy electrons which are necessary for generating useful X-ray beam. So what is the focusing cup made of? I showed you in the picture here. This U-shaped cup is the focusing cup. It is made up of molybdenum. This molybdenum is negatively charged, and the electrons which is expelled from the tungsten filament is also negatively charged. So basically, this focusing cup mainly serves to focus the electrons which are produced in the tungsten filament towards the tungsten target. Since this molybdenum is negatively charged and the electron produced is also negatively charged, there is some amount of repulsion created here, and so more and more of electrons expelled are pushed towards the tungsten target, thereby resulting in the production of useful X-ray beam. What is the use of insulating oil? When you take an X-ray machine, these are the components of an X-ray machine. I told it is enveloped in a glass lining. So in the tube head, when it is placed, you will have a tube head surrounding these components. Between this glass envelope and the tube head, there will be presence of the insulating oil. This is mainly because during the production of X-rays, which we will be dealing in the next class, I will be telling about how much radiation is produced and what are the types of radiation and all that in those class. But now I would like to tell you that during the production of X-rays, what happens is that 99% is dissipated as heat, and only 1% is produced as X-ray beam. So this 99% of the heat produced, if it is going to be inside the machine, it will destroy the components of the X-ray machine. So it should be expelled to the atmosphere. This insulating oil which is present between the glass envelope and the tube head will dissipate this heat produced during the X-ray generation to the atmosphere via the process of convection. That is the use of insulating oil. So why vacuum is necessary? See, you can see here a part is labeled as vacuum. This is because the components of in the X-ray machine are placed in an evacuated chamber. This is mainly because if in case we can imagine an air molecule is present here. Say for example, it is present here. A is an air molecule. So the electron is produced here. If air molecule is present here, this air molecule will come and collide with the high energy electron, which is expelled from the tungsten filament. So as this electron gets collided with the air particle, if in case it is present, the kinetic energy of the expelled electron will be reduced. It will be converted into a low energy electron. So low energy electrons are not purposeful, does not contribute to the production of purposeful X-rays. We cannot use them for our diagnostic purposes. So that is why we have to keep the chamber free of air molecules. So only we prefer a evacuated chamber. So what is the diameter and length of the tungsten filament? This is one numerical questions you can get any time in your any of the entrance examinations. According to the standard book references, it is said that a tungsten filament of 2 centimeter in diameter and 1 millimeter or less in length is preferred in an X-ray machine. So this sums up the demo class of Radiobytes. If you wish to join us, you can subscribe us for more.